In the previous section, we talked about using the first derivative to determine if a function is increasing or decreasing on a particular interval. So if the first derivative is positive, like here, it means that the slope of the tangent line is positive and the function is increasing. If the first derivative is negative, it means that the slope of the tangent line at a particular point is negative, which means the function is decreasing. And if it's equal to 0, then the function is constant. Now, in this section, we are going to talk about concave up and concave down. So first, let's talk about like the formal definition, and then we'll kind of determine how to tell if something is concave up or concave down just by looking at the shape of it. So a function is concave up over an interval if the first derivative, which is the slopes, are increasing. Okay, let's take a look at this first graph that's concave up. The reason it's concave up is because the slope at this point of the tangent line is -3, and then here it's 0, and here it's 3. So the slope is going from -3 to 0 to 3, so the slope is increasing, making it concave up. Now here, the slope goes from a +3 to 0, so it's decreasing to -3. So when the slopes of tangent lines go from positive to 0 to negative, slopes are decreasing, that is going to be concave down. Now what I do want you to notice is that for concave up, it makes a U shape. So imagine this is a cup and the water is going to be filled in this cup. That's concave up. Concave down makes an upside down U shape. So if you were to, like put water in this, it would spill. So concave up, concave down. A graph is said to be concave up at a point if the tangent line to the graph at that point lies below the graph in the vicinity of the point. All right, so let's break that down. A graph is concave up if the tangent line to the graph at the point lies below the graph. So we said here this graph is concave up. So I can take any point and notice the tangent line is going to be below the graph. Here, below the graph. Here, tangent line is below the graph. That's if it's concave up. Now, and it's concave down if the point at the tangent line is above the graph in the vicinity of the point. So if you look at this graph that's concave down, it's the upside down U. Any point you pick, the tangent line is going to be above the graph, above the graph, above the graph. All right, so if the tangent line is above the graph, it is concave down. And if the tangent line is below the graph, it is concave up. Okay, so let's take a quick example here. Let's say that my graph looks like this. Notice it's making a U shape. I can take any point and draw a tangent line, and that tangent line is going to be below the graph. This is going to be concave up. Now for concave down, which is this upside down U shape, I can pick any point, and when I draw a tangent line, it's going to be above the graph. So this is concave up, this is concave down. Okay, now a point of inflection is a point on the function where the concavity changes from concave up to concave down, or from concave down to concave up. And visually, it's kind of hard to tell. We just kind of have to eyeball it, but we're going to look at a way to find that inflection point using calculus. So here, this is concave up because up to here, notice that it's a U shape that's facing upwards. Another way for me to tell is I can take any point, draw a tangent line to that point. Now the tangent line is below the graph. So because it's below the graph, that means it's going to be concave up. Now at some point, the concavity changes. So notice that it's the U is facing up. And at this point, which is the inflection point, even up to here, the U is facing up. But at that point, the U starts facing down. And I can take any point in that concave down region, make a tangent line to it, and it's going to be above the graph, which is an indication that it's concave down. But but besides that, take a look. The graph is facing up. Here, the graph is facing down. Okay, down, up. Same thing over here. This is concave up because we're facing up here, and then at some point, we face up, face up, face up, and the concavity changes. And here on out, we're facing down. Again, this is concave down because here, if you notice, we're facing down, facing down, facing down. And then here we start facing up, facing up, facing up. Same thing here, concave up, we're facing up, facing up, facing up. Inflection point, facing down, facing down, facing down. So concave up, concave down. Another example, so we're going to put together the previous section and this section. So for each of these, we want to tell if the function is concave up, concave down, and if it's decreasing or increasing. So if I go from left to right, the function is going downwards. So all the slopes are negative, which means the function is decreasing. And then because the function is facing up, in other words, the tangent lines are below the graph, it is going to be concave up. So decreasing because from left to right, the function is going down, and concave up because the function is facing up. Here, going from left to right, the function is going up, so it's increasing. And then the tangent lines are below the graph, which means it's concave up. And we can also tell it's concave up because it is facing upwards. Now, in this third part, going from left to right, the function is going down, so it's decreasing, but all the tangent lines are above the graph, which is how we know that it's going to be concave down. In other words, here we're facing down. Here, this last one, the function is increasing because going from left to right, we're going up, and the tangent lines are above the graph. In other words, the graph is facing down, so this is going to be concave down. Now, how do we tell using calculus if something is concave up or concave down? Well, the first derivative tells you if it's increasing or decreasing. The second derivative will tell you if it's concave up or concave down. So if the second derivative is positive on an interval, the graph is concave up. If it's negative, the graph is concave down. And when the second derivative is equal to 0, or when the second derivative is undefined, that is going to be the point of inflection when this happens. Okay, so second derivative is greater than 0, concave up, less than 0, concave down, equals 0 or undefined, inflection point. So this example says at the point shown on the graph, which of the following is true? So at this point, we want to first determine, is the function concave up, is the function increasing or decreasing? Let's start with that. So the first derivative will tell you if the function is increasing or decreasing. And I'll write this over here for reminder. First derivative at any point will tell you if the function is increasing or decreasing. And the second derivative at any point will tell you if the function is concave up or concave down. Now, at this point, what I'm going to do, and the best way to tell is using a tangent line. So at this point, I'm going to draw a tangent line to the curve. Now, the slope of this tangent line is negative. From left to right, the tangent line is going down. And you can also tell the function is going down. So if it's going down, that means this function is going to be decreasing. Oh, you know what? Let me erase all this. Should have planned this a little better. Sorry. So I'll rewrite this on this bottom part over here. So the first derivative at any point C will tell you if the function is increasing or decreasing. And the second derivative at any given point will tell you if the function is concave up or concave down. So our tangent line, our slope, is negative. So if we have a negative slope, what that tells you is that the function is going to be decreasing. Now, if the function is decreasing, it means the first derivative is less than 0. First derivative will tell you if it's increasing or decreasing. Decreasing, so we have a first derivative that is less than 0. Then we have to determine, is the tangent line below or above the graph? So if the tangent line is below the graph, that means it's going to be concave up. If the tangent line is above the graph, that tells us that the first derivative is concave down. So here the tangent line is below the graph, which means it's going to be concave up. In other words, notice that it's making a U shape and it's facing upwards. It's like a right side up U, facing up, makes it concave up. Okay. Next example, it says over which intervals is f prime of x greater than 0. So remember, f prime of x greater than 0, this means it's a function increasing or decreasing. So if I go from left to right, the function is going up until we hit the x value of 0. And remember, for increasing, decreasing, we only measure the x values. Then between the x values of 0 and 2, the function is decreasing. Don't look at the y values, look at the x values. That's what we measure for increasing, decreasing. And then from 2 to infinity, the function goes up again. So it's going to be increasing in this red part from negative infinity to 0, and then from 2 to infinity. Only look at the x values. Where is a function less than 0? Where is it decreasing? Well, it's decreasing in between x equals 0 and 2. In this green part, it's going down. Next thing we want to know is where is it concave up? So in other words, where is the second derivative greater than 0? Where is it concave up? Now concave up, remember, it's making a U shape. In other words, like, where are we facing up? So we're facing up over here in this area. And the point of inflection is going to be this point, which is 1. That's the point of inflection. So from from 1 to infinity, it's going to be concave up. Notice that all these arrows are facing up. And then from negative infinity to 1, it's going to be concave down because all these are facing down. So look for the right side up U and look for the upside down U. And then where that changes is going to be the inflection point or the point of inflection. Next example, it says, determine the signs positive, negative, 0 of y equals f of x shown in the graph, and then f prime of x. Okay, so there's a difference between saying f of 2 and f prime of 2 and f double prime of 2. So let me go over each of these. So f of 2, it just means the y value when x equals to 2. So we're not looking at is it increasing, decreasing, or concavity. We're looking at literally the value. So if I'm looking at x equals 2, this is the corresponding y value. And notice the y value is below 0. So the y value is going to be negative. Now, what is the sign of f prime of 2? So for increasing, decreasing, or concavity, we're going to use a tangent line at that point. So at x equals 2, I'm going to draw a tangent line, which is that one. Now the tangent line is positive. It's going up. Slope is positive. So f prime of 2 is going to be positive. In other words, the function is increasing, which we can tell, right? Like it's going up. And then f double prime, which is the concavity, because the tangent line is below, we have concave up, which means the second derivative is going to be positive. For the next one, at x equals to 1, here, the y value is 0. If I draw a tangent line, the tangent line is decreasing. So f prime of 1 is going to be negative. And then the tangent line is below the graph. In other words, this is all facing upwards. It's making a right side up U. So the second derivative is positive, which means it's going to be concave up.